Please, let's give it up for Felix. Felix, join me over here.
Hello, good morning.
Thank you. Enjoy.
Thank you. So while my team, Jackie, is setting up something that usually you see a magician is doing teasing our processing box, and I asked our guest in the front line to be a witness of how this is processing underlying. So first, I'm Felix from Tiki 3D. New name to the audience, and I believe we are here in Interview last year, but I believe a lot of people, I meet so many new people here. I was raising and keeping my hands until the last last one in the morning. I meet definitely way more than 10 people at this venue. So, who are we? Well, I am no new guest to the European market, and I have many friends here. First, I'm born in Shanghai from China, and then immigrant to New Zealand and took my degree in New Zealand and got my master in Australia, where you should easily pick up from my accent, g'day mate. And then I moved back to Hong Kong, and there are some story with reality capturing. So I've been in the reality capturing game since 2010. I was talking to some early adopter or software vendors, including, say, Saab Dynamic, while the technology was called rapid mapping. And then I'm the guy bringing Accu3D to Asia. And in 2015, it got acquired by Bentley, and I became a regional industrial sales director for the product. And founded Tiki3D since 2018. While what I see what's lacking in the market is the focusing on a large-scale municipality-scale project that's really utilizing the 3D mesh, reality capturing technology in the massive scale. And sharpen up the skill for 6-7 years now. I think we are ready to show what we got to the EMEA European market. So this is what we got. So our product line comes across processing software and hardware, capturing, and some industrial application. I'll go through several of them. Because of the short time frame, the shadowing actually spoil all the information. So we believe we're the regional leader in reality 3D modeling software, and from where we're coming from. And from day one, it's designed for mass production with quality and productivity in mind. So first step, AT. So we give our branding is infinite. So InfiniteArt is like we process aligning hundreds of thousands of images in one go. You don't have to manually split them. And our latest versions, it can be processed within 4 hours for the alignments with a single normal desktop PC. Reconstruction, the algorithm is the architect is multi-engine grid computing architect, so it's similar to a lot of the other softwares. But the differentiator is we allow multiple instances of engine running on the same hardware, which squeezing out all the processing capabilities even further. So from some customer reviews, we can pump up the productivity as much as over 300% compared to some existing solution they're using. I believe a lot of our audience guest has been introducing. They are capturing not only airborne surveying method, but also close-up technology. So multi-dimensional, multi-resolution, or even airborne, terrestrial, handheld, all kind of different equipment. So we have a special algorithm in our triangulation mode for mixing and automatic fusion of the aerial, terrestrial, you name it, different kind of hardware. And also, we have a separate module that processes stereo satellite image into a 3D mesh. Automation. When you're talking about mass production, customers don't want to sit in front of their computers 24/7. So a lot of automations need to be carried out. GCP, it's always the pain point, and we overcome the hurdles by automatic picking up the targets and so on. Auto-referencing AD, that's something I will introduce in a few seconds, and a lot more. So AT, or alignment, is the first step of all the processing. And why AT? I use a video clip to show how much pressure our clients actually put to us by a madness of way of capturing from all different angles, all different resolution. They want the ground level in centimeter resolution. So this is really something that actually puts a lot of pressure for traditional photogrammetry software. And that's we come in and doing a lot of tweaks in the algorithm and optimizations for that. So robustness, efficiency, and scalable. That's what we introduced our super capacity mode. It's one of the 4 aero triangulation mode in our software. This year we're introducing the second generation in our 2025 version. So it's set up a record-breaking auto sub-blocking and fusion algorithm. So it's really pushed the boundary of, say, millions of images going through the AT alignment process on itself. And the accuracy, of course, is consistent across the sub-blocks. And just by a normal desktop with 64 gig of RAM, it can process over millions of images. So a couple of showcase, and I'm showing the hardware spec that we are using in the test case. 142,000 images, throw them in, load them in all together, and let the software run by itself. It's automatically segmentations into small chunks and then automatically fusing them with the consistent of accuracy. So the total processing time for the aero triangulation is 6 hours and 15 minutes. I don't know your experience of processing a similar data set, how long it would take. From our feedback, this is mind-blowing. And in the 6 hour 52 minutes, feature extractions is 1 hour 45 minutes, and bundle adjustment is 3 hours and a half. That's what we got a feedback since never has been achieved before. What about bigger ones? So 647,000 images again, put through the same machine, 64 gig of RAM. Of course, it takes longer because of the total number of images processed, and it's pushing the bundle adjustment in another scale. But again, with a single machine, 62 hours, we've got a job done. And with the RMS 0.7. All right, so we covered the scaling. Another thing that has been demanded a lot, especially useful in the cases of repetitive scanning on the same site. for example, construction site, mining site, that especially these days with docking station in place, that people got drone flying over the site every week, every couple of days, want the data to be updated. So, and also there are AI or change detection algorithms which are relying on the pinpoint accuracy of alignment for several data sets. So, and some of the project we experience, and then they have some small structures changed, progress in the time frame, and it's not big enough or not substantial enough to be able to create some GCP for this. Of course, we have the tools of, say, RTK drones and everything, but drone-based RTKs that still give you around, say, plus or minus 2 centimeter accuracy, while if you require higher accuracy based on that, it's difficult. So with our new auto-referencing algorithm, you only do GCP once for all, for the very first ground-based data set. Everything update data set capturing, you never need to worry about GCP. It's auto-referencing to the previous data set and auto-alignment, not only the data set by itself, but also the referencing data sets. So while we're talking about GCP, even for that data set, we're just having thousands of images, literally, there is a money cost involved. So people can do hundreds GCPs, 150, 200, because that's time and labor-intensive work. But with the referencing feature, we actually have thousands of features from existing data sets, which makes the matching even more reliable. And we can provide pixel-level accuracy for the alignment between the data sets. Sometimes the pixels have higher resolution compared to what the drone RTK can achieve these days. So this is a typical use case for some construction site with the old data set, which is already still inbuilt, including the road. And the customer, of course, want a updated data set with a new constructions in place. With that kind of scenario, you never need to worry about controlling or GCPs anymore. You just fly over, and it's automatically aligned. Okay, so enough for error triangulation. Reconstruction. So we believe we are in the first tier quality. Of course, people want market want a good quality 3D reconstruction. It's difficult to tell whose is really good compared to the other one. And I'm dear enough to come to Europe to say say this, but I would say from the user feedback experience, we are sitting in a comfortable position that we don't have major or substantial difference comparing to geometry as well as the texturing qualities to our outputs. Multi-node computing, that's what we a lot of software are actually using these days of grid computing and scale out of projects into well, 10, 20, or hundreds. From our market sector, the largest production facility we build for our client, private cloud, is more than 215 processing nodes in the same processing facility. And as I mentioned, we allow multi-instance processing engine running on the same hardware, which pumps up the number of engines running in the network from 250 physical machines to more than 800 running engines in the network, which gives us more than 3 times more productivity from the same hardware and the same data set. Of course, the new fancy outputs, 3D Gaussian splatting, we also support that. So here are 3 efficiency test cases that we have. For a data set of, say, a few thousand images, we pump up to, if you're looking at the processing time, 2 hours, 2 hours, 20 minutes, about 4 hours. So the efficiency of processing based on the just a few nodes of the day-to-day machine. And if you're considering, say, big gigapixel-wise, we are be able to achieve per node per day 300, comfortably above 300, almost 400 gigapixels per day. And square kilometer-wise, remember we are talking about 3 centimeter or 2.5 centimeter resolution, and we are be able to pump up to 3. That one's slightly less, almost 3 kilometers per node per day. So imagine you put that into scale. So I use a small video clip to prove that our production quality. So this is a typical eastern town. Quiet, classic, with a golden Buddha sitting across the river and looking over the town. That's a typical mesh you can get these days, but we didn't stop there. Gaussian splatting. So this is a video clip that shows a typical scene that you usually get not so satisfactory result from a mesh. So you see all these palm trees, leaves, and the see-through glasses and the balconies, these thin wire structures that's usually either missing or distorted in a static 3D model like a mesh. But they are represented perfectly in 3D Gaussian. And we share the same workflow of the photogrammetry part, which is alignment and error triangulation and the dense point and coarse point cloud and dense point cloud. And we can scale that up into grid computing to push the data to be processed in multiple machines. And we also have the same old-fashioned algorithm to split into tilings and auto merging. And in the end, we output the major formats, PLY, splats, 3D tiles, and then we also have our first generation of LED technology in the pipeline. So enough for the software. If you remember in our hierarchy, we also provide the processing hardware side. The reason being is we're talking about mass production. And we're not talking about, sometimes the customers have limited IT infrastructure in place. And as a lot of guests already mentioned, when you're talking about hundreds of thousands of images, that's completely the game changer if you only have experience to process a few thousand, 20,000 images. So here's the big boy toys for all the RC community. So we coming from building up the GPU dense rack servers to mobile processing cards and hand carry size of the all-in-one processing box and the tri-screen. And I'm not going to go into detail here. So we have a booth here, so if you're interested, feel free to come over and have a quick look. So the last slide, I actually going to review what we are actually doing here is real-time streaming processing. So this is thanks to our partner 3Gon. We actually got a data set, more than 500 images of a European farm. as soon as I start my presentation, the computer is running a simulation of streaming the images from the drawing to the box and got processed in real time. And now, by the time I finish my process, the data are already completed. So for any of you that can't see the screen, I have a recorded footage that's showing how fast we are able to process. Remember, we are streaming the original resolution of the full image and got processed, and output of the mesh is still haven't been shrink down. So yeah, we have a booth there, so if any of you interested, please come over. Thank you very much for your time.
Perfect. Ladies and gentlemen, let's give it up for Felix.